A magnitude 4.3 earthquake struck Northern California on Tuesday night, and within hours the United States Geological Survey had logged 162 separate seismic events in the sequence that followed. The agency did not classify it as an isolated earthquake. It classified it as the potential mainshock of an earthquake sequence. That word, potential, carries the unresolved uncertainty of this branch of science, because the classification is only ever available in hindsight. The fault involved is one almost nobody outside working seismology has heard of, and it had already moved once, 5 weeks earlier. It runs southeast, toward the most densely populated corridor in Northern California, and its buried geological record holds ruptures substantially larger than anything in its modern instrumental catalogue. The rupture came at 6 seconds past 7:40 on Tuesday evening, Pacific Daylight Time, or 2:40 Universal Time, coordinated on July 29, 8 kilometers east-southeast of Cloverdale in Sonoma County. The USGS put the magnitude at 4.3, revised upward from an initial 4.2 within the hour. Depth was 5.5 kilometers according to the national catalogue, and 6 kilometers according to the reviewed Northern California listing. Either figure places the rupture inside the shallow, brittle upper crust, the layer where shaking is felt hardest relative to the energy released. 38 seconds later, a magnitude 2.5 struck in nearly the same place. Nobody was hurt and no buildings came down. The USGS automated impact system issued a green alert for both fatalities and economic loss, the lowest category the scale has. More than 520 people filed felt reports through the agency's Did You Feel It system, from Healdsburg, Geyserville, Middletown, and Kelseyville close in, and from Roseville, Elk Grove, and San Francisco more than 100 kilometers away. The USGS noted that shallow earthquakes like this one produce stronger surface shaking, which explains reports arriving from as far as 140 kilometers out. Some reached Nevada. Maximum recorded shaking hit intensity 5 on the modified Mercalli scale, which measures observed effects rather than energy released. Intensity 5 is dishes rattling and pictures going crooked, not structural damage. The ShakeAlert earthquake early warning system activated. State Senator Mike McGuire, whose district covers northern Sonoma County, posted that it was a good-sized shaker with no early reports of damage or injuries. On an ordinary week, a magnitude 4.3 in Northern California is a local news item. It gets a paragraph, a map graphic, and it disappears. What separates this one has nothing to do with how hard it shook. It showed up in the agency's own data feed within hours. Aftershock productivity, the number of smaller earthquakes a rupture generates, scales with the size of the main shock. For a magnitude 4.3, the statistically expected population is a handful of events, maybe a dozen, decaying quickly and quietly within a day or two. A sequence population of 162 is not that. That is high productivity, and high productivity says something specific about the condition of the surrounding rock. When a single locked patch on a fault fails cleanly and settles back down, you get a small, contained aftershock population. When a broader volume of crust is already sitting close to its own failure point and one piece of it lets go, the resulting stress redistribution can light up everything nearby. The USGS forecast for the sequence put the chance of at least one additional magnitude 3 or greater event within the following week at 28%. That window opened Tuesday night and closes on August 4th. The location matters as much as the numbers. The Cloverdale epicentre sits within the Maacama fault system, a right-lateral strike-slip fault, meaning two blocks of crust grinding past each other sideways. It runs northwest to southeast through the Northern California Coast Ranges, east of the far more famous San Andreas, dipping somewhere between 50 and 70 degrees to the east. It carries a substantial share of the motion between the Pacific and North American plates through this part of the state, motion that has to be absorbed somewhere and that the San Andreas alone does not account for here. According to the deformation model built for the 2023 National Seismic Hazard Model, the Maacama slip rate sits at roughly 9 mm a year, plus or minus 1.5. The offshore San Andreas in the same region runs at about 24 mm a year, the highest rate on the local map, and yet that section has produced almost no catalogued earthquakes at all. The Maacama also creeps. Creep is slow, continuous, aseismic movement, the two sides sliding past each other gradually without producing an earthquake. On the Maacama, that rate runs between 2 and 6 millimeters a year. Paleoseismic work at Willits measured it at 5.7 millimeters a year, averaged over 2 decades. It is visible in the built environment, where curbs and infrastructure crossing the fault trace have been measurably offset sideways over time. Creep is often described publicly as a pressure release valve, and that framing is where a lot of casual reassurance about faults like this comes from. It is incomplete. The researchers who documented this fault's recent behavior state directly that while creep does bleed off some potential seismic energy, seismic strain is still accumulating along the fault, and can be expected to release in earthquakes. If the fault moves roughly 9 millimeters a year and creep accounts for 2 to 6 of them, then somewhere between 3 and 7 millimeters a year is not being released aseismically. That residual accumulates as stored elastic strain in the rock. Tuesday was also not the first movement on this fault this summer. On the morning of June 24th, at 8:10 local time, a magnitude 5.6 struck near Ukiah in Mendocino County, roughly 11 kilometers north of Redwood Valley. The epicenter was directly beneath the Abhayagiri Buddhist monastery, in a sparsely populated stretch of mountainous forest. It was the largest earthquake in the USGS catalog on the Maacama Fault, and the largest anywhere in California since the magnitude 6.4 near Ferndale in December 2022. Shaking was severe close in. Seismometers within 10 kilometers recorded intensities of 6 to 8. The USGS impact model estimated about 10,000 people experienced intensity 7 shaking, with another 10,816 at intensity 6, and more than 4,500 felt reports were filed. Thousands of Mendocino County residents lost power, around 5,000 in the Willits area alone. There was minor damage and there were injuries, but no deaths. The focal mechanism matched the Maacama closely, with one nodal plane oriented northwest to southeast, dipping 54 degrees to the northeast. USGS seismologist Sarah Minson said the earthquake likely ruptured the Maacama, which she described as a northward extension of the Hayward and Cloverdale systems. Amy Williamson, a research scientist at the UC Berkeley Seismology Lab, called it the largest quake on that fault in 75 years. June 24th carried a second lesson. ShakeAlert, the earthquake early warning system covering the West Coast and the most advanced public system of its kind in the Western Hemisphere, worked as designed. It detected the rupture and issued an alert. The first message went out 5.5 seconds after the earthquake began. In 5.5 seconds, seismic energy had already traveled outward roughly 18 kilometers, so everyone inside that radius was being shaken before the alert was generated, and transmission time expands that blind radius further. The researchers who documented the case stated the conclusion plainly. These systems are not predictors, but rather detectors, and will never provide timely warnings to epicentral areas. That is not a criticism of the system. An earthquake has to begin before anything can detect that it has begun. While examining the seismicity around the June rupture, the researchers tracking this fault found something they could not identify: a distinct linear band of earthquakes running between the Maacama and the nearby Bartlett Springs fault. It appears clearly in the catalogue as a concentrated linear cluster, the signature of an active structure. It does not appear as a fault trace in the National Quaternary Fault and Fold Database, the authoritative United States inventory of faults officially considered active. California's own state geological mapping shows structures in that area but classifies them as pre-quaternary, meaning not currently active. The researchers publicly asked for help identifying it, and a USGS seismologist pointed them toward a 2013 paper in the journal Geology describing the same structure. So there is a seismically active structure in the Northern California Coast Ranges that is not fully accounted for in the National Active Fault Database. The earthquakes are sitting in the public catalogue for anyone to see. They are simply not yet assigned to a named, mapped fault. The Maacama's deeper history runs longer than its instrumental catalogue. Excavation of sediments at Hayward Creek near Willits identified fault offsets pointing to at least 2, and possibly 3, large surface rupturing earthquakes within roughly the last 1,200 years. In the last 560 to 690 years, a buried channel deposit has been offset 4.6 meters, implying co-seismic slip of up to 1.7 meters. That study deliberately assigned no magnitudes, because converting a single offset measurement into a magnitude is not defensible. Researchers reviewing the record, flagging clearly that they were estimating informally, put the likely size at magnitude 6.5 to 7 or larger, on the reasoning that smaller earthquakes do not leave this kind of preserved geological trace. The magnitude scale is logarithmic at roughly 30 times per unit, so a magnitude 6.6 would release about 30 times the energy of June's 5.6. Following the structural trend southeast is where this stops being abstract. The Maacama is the northward continuation of the Hayward and Rodgers Creek system. For decades there was an open question about what happened to the Rodgers Creek fault once it reached San Pablo Bay. In 2016, subsurface imaging led by USGS researchers and published in Science Advances answered it. The Hayward and Rodgers Creek faults are directly connected beneath the bay, with the Hayward bending about 10 degrees to the right as it crosses. They form one continuous structure, roughly 190 kilometers, or 118 miles, from Alum Rock in the south to just north of Healdsburg. The maximum modeled magnitude for a full combined rupture is 7.4. Lead author Janet Watt noted that would release more than 5 times the energy of the 1989 Loma Prieta earthquake, which killed 63 people. That figure needs a qualifier. Multi-fault ruptures spanning a connected structure are real and documented, but considerably rarer than single-fault ruptures confined to one segment. And to be clear about what is and is not being claimed, a magnitude 4.3 near Cloverdale does not load or stress the Hayward fault. There is no mechanism by which it could at that distance. The connection is structural, not causal. Roughly 19 hours before the ground moved near Cloverdale, a shallow crustal earthquake ruptured beneath Kumamoto Prefecture in Japan. The Japan Meteorological Agency measured it at magnitude 7.1. 36 people are confirmed dead as of August 1st, and more than 267,000 remain under evacuation orders. That is where the coverage went, and where the damage was. Japan also supplies the case study that makes the California sequence worth watching, and it comes from the same fault system. On April 14, 2016, a magnitude 6.5 struck the Futagawa and Hinagu fault zones beneath Kumamoto. It was treated as the main event. Emergency response mobilized and people moved back into damaged buildings. 28 hours later, a magnitude 7.3 struck the same system, and the first earthquake was reclassified as a foreshock only after the second arrived. No physical property distinguishes a foreshock from a mainshock at the moment it occurs. The base rates are well established and reassuring up to a point. Worldwide, the chance that any earthquake is followed by a larger one nearby within a week is about 5%. Within 3 days, it is just over 6%. In California, the USGS puts the 1-week figure at 5 to 10%. But that baseline varies with the activity level of the sequence, and sequences with more aftershocks than average are more likely to be followed by a larger event. The Cloverdale sequence has 162. The signal to track is not the next magnitude number. It is the shape of the aftershock distribution. If aftershocks stay tightly clustered around the main shock, that is a normal sequence decaying and releasing local stress. If they elongate along the fault trend, northwest toward Ukiah and the June rupture, or southeast toward Rodgers Creek, that indicates stress transferring onto adjacent segments, and segment-to-segment progression is how a moderate sequence becomes a larger one. The USGS forecast gives one concrete checkpoint. At least one magnitude 3 or greater in the Cloverdale sequence within a week of Tuesday. Where that event lands will matter more than whether it happens at all. That window closes on August 4th. We will be tracking it.